Hello, everyone. Welcome back to the AAS YouTube channel, and this is part of the good stuff. This is the AAS Journal Author Series, and I'm very happy to have Catherine Clark with us today. Hey, Catherine.
Hello, thank you so much for having me.
Well, thank you for agreeing to talk about your really lovely research note.
Happy to do it.
And Catherine, where are you located at?
I'm in Flagstaff, Arizona, which
Ooh, Flagstaff.
a bit north of you, a bit colder here than Phoenix.
Yeah, we're separated by roughly about 100 miles or something thereabout, depending exactly where you go in Flagstaff. So I imagine at that elevation, you have snow in Flagstaff.
We do. We have some snow on the ground. We've actually gotten a decent amount for it being January. I'm looking forward to doing some skiing.
Made any snow angels?
Not yet. We'll have to do that.
But skiing, so you ski?
I do ski, yes.
Very good.
I grew up in Colorado, so.
There we go. There we go. Whereabouts in Colorado did you grow up, roughly?
Denver.
Boulder. Okay.
Denver, actually.
Oh, Denver. Okay. Yeah. So then you head to the west a little bit to hit some mountains there. Very cool. What is your position there at NAU?
I'm a fifth-year PhD candidate at NAU. I also work as a graduate research assistant at Lowell Observatory.
Oh, very good. And when do you anticipate graduating?
May. Fingers crossed.
Oh, very cool. Well, congratulations on almost being Dr. Clark.
Thank you. I'm looking forward to it.
That'll be awesome. Very cool. Catherine, what do you like to do for research?
I study the coolest and faintest stars on the main sequence, the M dwarfs, and I use high resolution imaging techniques to look for them in multi-star systems.
Very cool.
Implications for detecting and characterizing the planets that orbit them.
There we go. Very nice. Very nice. And that is going to bring us to this very lovely research note. Open access, people. New stellar companion to TYC 5493-889-1. That's a mouthful. And Catherine, take us away.
Yeah, all right. Well, first I want to shout out my advisor, Dr. Gerard Van Bell, and our collaborator, Dr. Elliot Horch, for their participation in this research note. So like I said, I study the M dwarfs and I look for them in multi-star systems. For this work, we were using Speckle Imaging. So if you're not familiar, it's a high resolution imaging technique where you take short 40 millisecond exposures of your target and you take 1,000 exposures per data cube. This allows you to freeze out the atmospheric interference from your data in post-processing. Cool. Because 40 milliseconds is how long an isoplanatic patch lasts in the atmosphere. Okay. And so your resultant images are diffraction limited. So this is what we were using when we serendipitously discovered this new stellar companion. The study I was working on when we discovered this companion, we were trying to determine the fraction of planet hosting M dwarfs that have a stellar companion as compared to the fraction for non-planet hosting M dwarfs. This work was recently submitted to AAS journals, so keep an eye on the archive for that.
We're gonna have to do a video on that one.
Yeah, have to come back. Great.
You get to be a double shot. Very good.
Yeah, I get to do a longer one. This one is a quick little research note.
Very cool. Serendipitous discovery.
Yeah, it's kind of a surprise. So our sample of planet hosting M dwarfs for this study came from the Transiting Exoplanet Survey Satellite, or TESS, and its list of TESS objects of interest, or TOIs. These are the most promising planet host candidates discovered by TESS. So when we discovered this stellar companion, we were attempting to observe TOI 732. Okay. We were using the Differential Speckle Survey Instrument, or DISI, on the 4.3 meter Lowell Discovery Telescope, or LDT, which is outside Flagstaff, Arizona. And we found a stellar companion to what we thought was TOI 732.
Wow.
However, soon after, two papers popped up on the archive that presented two new planets orbiting TOI 732. And one of these papers included high resolution images of TOI 732 that showed no stellar companion at the 5 sigma level.
Okay.
So this led me to investigate our own detection a bit further.
Yeah.
So on the same night, we also observed Van Altena 351, which has a similar R magnitude to TOI 732.
Okay.
However, our observation of what we thought was TOI 732 had a much higher signal to noise ratio than the Van Altena 351 observation.
Okay.
This should not have been the case, considering they have similar R magnitudes.
Mhm.
And it could not be explained by the improved seeing that we saw over the course of the night.
Mhm.
So upon further investigation, we found that the field surrounding TOI 732 included many other stars, including brighter stars. And one of these was Tyche 5493-889-1. It's kind of a mouthful, as you said, so I'll just refer to it as the Tycho star from here on out.
There we go. I like that. There we go.
So this Tycho star is 33 arc seconds away from TOI 732, and it has an R magnitude that is consistent with the signal level that we detected in our observation.
Okay.
It's pretty unusual for this to happen. The LDT has superior pointing, but TOI 732 is nearby, so it has high proper motions, and we were likely a little bit off with ours, putting it in the wrong place by 33 arc seconds. So once we found this companion, or this star rather, the Tycho star, we checked Gaia ADR3 as one does, and Gaia ADR3 does not list a parallax for this star.
Okay.
This often occurs in close-in binary systems. Gaia is unable to resolve the system, and the relative motion of the pair disrupts the parallax measurement. So this was further evidence that we observed the Tycho star and not TOI 732. We also checked the Washington double star catalog for this companion and the fourth catalog of interferometric measurements of binary stars, and it does not appear in either of those catalogs. And so we concluded that this is a newly resolved companion. So we decided to do a bit more analysis on this system. So we used the 20-inch Titan monitor, or TIMO, facility at Lowell Observatory to photometrically observe this star. And we fit a spectral energy distribution to the TIMO observational data, and this indicated a spectral type of F1b, which is definitely not an M-dwarf.
No, definitely. Okay.
Yeah, so we then did a little deducing based on the primary star spectral type estimate and the observed delta magnitude for the system, which was 0.61 at 692 nanometers and 0.59 at 880 nanometers. We determined that the secondary is likely a later F-type star as well.
Ooh, okay.
So since Gaia ADR3 does not list a parallax for this object, we calculated a photometric parallax using the reference absolute V magnitude for an F1 star and the apparent V magnitude for the Tycho star from the literature. Our calculated photometric parallax corresponded to a distance of roughly 320 parsecs. It's much easier to detect companions to F-type stars at this distance compared to M-dwarfs. M-dwarfs are quite faint. They would be difficult to see that clearly at 320 parsecs. For comparison, TOI 732 that we thought we were observing is at a distance of roughly 22 parsecs.
Oh,
so
wow. Okay.
Much closer.
Factor 10, yeah.
Yeah, so since we detected this stellar companion at a separation of 0.3 arc seconds, this corresponds to a physical separation of roughly 95 AU. If we assume that the instantaneous spatial separation is approximately the semi-major axis. So making a lot of assumptions there, but just preliminary physical separation. So this is our figure, our actual detection of this companion. On the left, you can see the star, the Tycho star, and its pretty obvious companion compared to some of the M-dwarf companions that we detect. You see 3 peaks. These can occur in the reconstructed image when the SNR is not high enough to determine the quadrant of the secondary during post-processing.
Okay.
So on the right side of the figure, we have the contrast curve as a function of angular separation. You can see the local maxima and local minima in the reconstructed image marked by boxes and dots. You can see 2 local maxima that occur below the red contrast curve. These are the companion and the ghost peak. So is further evidence that these are an actual companion and not just some background noise in the reconstructed image.
Got it. Got it. Cool. Very nice. Okay.
Yeah.
Awesome.
So if we pop to the bottom, we have all of our final data products for this object available through the Exoplanet Follow-up Observing Program database. And also want to give a shout out to NumPy for helping us with our analysis. Yeah, it's exciting to find a new companion to an F-type star. I've never done that before. It's been mainly all M-dwarfs for me. So this was a funny, serendipitous, exciting new discovery.
That is so awesome. That is so awesome. Thank you, Catherine, for walking us through your lovely research now. So you touched on it a little bit, but let me follow up. Sort of where do we go from here? Given the discovery, are there plans? At least your plans. Maybe there are other plans you don't know about, but maybe there are plans to do a follow up on this binary with other telescopes. Yeah. So what do you think?
I currently don't have plans to follow up this binary in particular. Though it would be fun to do so with some other instruments and some other techniques. In terms of my larger plan for follow-up, like I said, I submitted this paper where we've been following up M-dwarf TOIs with Speckle Imaging. So that should hopefully be out relatively soon. And I'm also, like I said, just trying to finish up my dissertation. We've also been doing the largest speckle survey of M-dwarf multiplicity to date, the Pokemon survey. So trying to finish that up as well before I defend. And yeah, just currently on the job market looking for postdocs.
Shout out. Hire her.
Yeah, a little shout out. So yeah, just trying to figure out what that next project is going to be. Have a few different ideas of things I want to follow up on. So those are the main next steps right now.
Very nice, very nice. Like I said, I will once I see your submitted article show through, we'll be in touch and we can do one on that one since this one's a little short, but it's all good. It's all good. So until then, good luck with finishing up your thesis and graduating and becoming Dr. Clark. And once again, thank you for walking us through your very lovely research note.
Thank you so much for having me.
And that'll do, everyone. And I hope this makes your astronomy day just a little bit better. And we'll see you on the next one. Bye-bye.